You're listening to a Frequency Podcast Network production in association with CityNews.
Anyone who has watched a loved one struggle with it, anyone who has tried to learn about it, anyone who has researched it can tell you, Alzheimer's disease is something of a mystery. There's just so much we don't know about it. There are few, if any, reliable treatments, and we have only, in the past few decades, even begun to understand some of its secrets. So the last thing that Alzheimer's research needed was this.
Alzheimer's research that has been used to treat possibly millions of victims and the target of untold billions of dollars spent worldwide is possibly based on a fabrication.
Scientific research on a subject builds upon itself. Each published study, each verified result, another brick in the wall. Every conclusion informs somebody else's hypothesis. And the research paper at the center of this scandal has been cited more than 2,000 times in the decade and a half since it was published. If that paper truly contains fraud and fabrications, where does Alzheimer's research even go from here? How much toil and money will have been wasted? How much false hope given to patients and their families? How many scientists sent back to square one? If Alzheimer's disease itself is the mystery, this is a hell of a plot twist. I'm Jordan Heath Rawlings. This is The Big Story. Charles Piller is an investigative journalist for Science Magazine. Hello, Charles.
Good morning.
Before we get into the study and the investigation that followed from it, maybe to set it up for us, can you explain why Alzheimer's has been such a tough nut for us to crack in terms of diseases? What don't we know about it?
Well, that's a good starting point because maybe the answer is, what do we know about it? It's a complex disease. It's was defined all the way back in 1906 by a German pathologist who the disease is named after. And what he saw were these things that are called plaques and tangles in the brain tissue of a deceased dementia patient. So these plaques are protein deposits, and a specific type of protein called amyloid beta protein was identified as a main component of the plaques back in 1984. So there's a lot known about these plaques and their possible interaction with dementia and Alzheimer's generally, but there's a lot of mysteries as well. There's genetic associations with Alzheimer's. There's thoughts that other factors might influence the disease, including inflammation. And to many scientists, it remains a gigantic mystery because despite all their best efforts, there hasn't been a good drug ever produced for Alzheimer's that really turns the disease course back or prevents it from happening altogether. What scientists really have come to understand is that there are more than one factor in Alzheimer's disease associated with that dementia. And stopping amyloid deposits, these sticky plaques in the brain cells caused by this certain protein, became the most plausible therapeutic strategy over a period of years of study. And the problem has been that hundreds of clinical trials targeting these amyloid deposits, either trying to reduce them or prevent them from occurring, have yielded really very few glimmers of hope in the field. Just really one anti-amyloid drug has gained FDA approval, and that's the one that was approved last year called Aduhelm. And that drug was very controversial because the evidence of its efficacy was very thin. And consequently, we're in a situation where many scientists in the field feel very strongly that amyloids are the target you should go after. But unfortunately, their efforts to actually use that to fight the disease have been very disappointing.
And we could do an entire hour-long episode about the history of Alzheimer's research, but we're here to focus on, I guess, the past 15 years or so. And it begins with, I guess, what must have appeared to be at least the resolution of one of the mysteries. Can you explain what was published in Nature and by who in 2006? Why was that study so important?
Sure. So at the time this study was published in Nature in 2006, the field had begun to see another kind of amyloid as a critical part of the Alzheimer's puzzle. And this is something called amyloid oligomers. Now, this is a subtype of amyloid proteins that, unlike these sticky deposits that had been the focus for so many years and are really still the focus of many scientists, these oligomer types of amyloid proteins are soluble. They don't cause these deposits, but they're toxic. And so this idea of the toxic amyloid oligomer hypothesis had gained a lot of currency around the beginning of the 21st century. And so more and more scientists were thinking, well, this could be an important leg up on this. But there was a problem. The problem was cause and effect. Could you actually demonstrate in an experiment that these oligomers, these so-called toxic oligomers, actually were directly related to dementia? And so what happened was that a brilliant experiment was conducted at the University of Minnesota by two scientists and some additional colleagues, but the primary scientists were Sylvan Lesny and Karen Ashe. So Karen Ashe is an illustrious, highly regarded scientist who has made major contributions to the field in her career. In fact, some people have spoken about her as being a possible Nobel laureate sometime in the future for the contribution she's made. So right off the bat, you have to understand that this study came from a very respected source. Lesny was her junior colleague, was actually a junior scientist working in her lab who was regarded by Ashe and others as quite brilliant experimental neuroscience expert. And so the study that they did purified a particular kind of protein that they discovered. Actually, Lesny is credited primarily as the discoverer of it, something that they termed amyloid beta star 56. So I'll just call it star 56 as a shorthand. And this protein, this toxic oligomer, this soluble oligomer protein, was purified out of the brains of mice. Now, these are special mice that Karen Ashe herself had developed that produced a lot of amyloid. So they were a great model for scientists to study Alzheimer's. So they took this protein out of the mice's brain and purified it. So they had this purified sample of amyloid beta star 56. And then they injected it into rats, and suddenly the rats showed cognitive decline, memory decline, that is akin to some of the symptoms of Alzheimer's disease in humans. So this was the first time that scientists had taken any particular substance and seemed to prove that it could directly cause cognitive decline, and in a very fast way. So it was a breathtaking result. It was a result that grabbed enormous attention in the field at the time. Along with their article in Nature, an editorial was published extolling the incredible creativity and importance of this study as a path forward, possibly, for curing Alzheimer's disease.
How did that study inform continuing research into Alzheimer's? I'm trying to figure out how much of the field focused on the results of that study in its wake.
Well, let's look at it contextually. At this time, as I mentioned, this amyloid beta oligomers, these soluble toxic oligomers, were gaining currency as a possible cause of Alzheimer's. And so many people were interested in these. What this study did is it supercharged the interest. And the reason behind that is that people were looking for this evidence of cause and effect. And for people who were thinking that this was the path forward, it confirmed their concerns, and it encouraged people in the scientific community to go after these oligomers and to go after star 56 as well as one of them. The budget for the National Institutes of Health during this period went from near zero being spent on these oligomers for Alzheimer's disease to today's spending of $287 million a year. So you're talking about really well over $1 billion being spent on this during this 15-year period. And obviously it wasn't solely due to the influence of this one study, but this study really pushed the field. Pharma companies also have spent enormous sums of money trying to develop anti-oligomer drugs during the same period. One sign of how important this study was, and it's not the only measure of influence in the scientific community, but it's an important one, is that this study has been cited in more than 2,300 other scholarly papers in the field in the period since it's been published. And during that period, there have only been 4 other scientific studies that have had more citations than this study. So it's the 5th most cited basic research study in Alzheimer's disease in that 16-year period, which is an enormous measure of influence.
And to this point, it's a good news story. It's a scientific breakthrough. It informs research. It drives funding. And here's where we start to get a curveball. Maybe begin this part by telling us, who is Matthew Schra and how did he end up investigating the study we're discussing?
So Matthew Schra is a junior professor at Vanderbilt University. He's a neuroscientist and physician. So he treats patients who have cognitive decline, and his lab looks at Alzheimer's disease and other neurological problems. So he's an expert in this realm. He got a bit of notoriety back last year during the period at which Aduhelm was approved by the FDA. That's the single Alzheimer's drug attacking amyloids that has been approved by the agency. And he was critical of that decision because of the benefits seeming to be so thin and the controversy around the drug as a result of that. His name was sort of in the mix of people who were interested in this and were willing to be courageous enough to speak out. What happened was that Schra was approached by a colleague of his who was connected to a group of scientists who were very concerned about another drug that is targeted against amyloids as well as other factors in the development of Alzheimer's disease. And this is a drug called simufulum, which is developed by Cassava Sciences. So there were scientists who were concerned that the results of this drug in their early studies were suspect, and they felt that some of the research associated with simufulum was actually not reliable because some of it had perhaps been falsified. So the stage this drug was in was clinical trials. In other words, FDA had approved it to go forward to be tested in human beings, and these scientists were concerned that those people might possibly be harmed by side effects of the drug or simply not helped because the drug's premises maybe were not well supported by the research. 2 of the scientists who were concerned about this are also short sellers. And for folks who know how the stock market works, you'll remember that short sellers are people who profit if a stock price declines. So they are making a bet that the stock is going to be in decline. And so it's complicated because these are neuroscientists and experts in neuroscience who also believed that this drug was terrible and were short sellers, so they stood to profit if the stock price of Cassava Sciences declined. So it's a complicated situation, not without its own conflicts of interest. So basically what happened is Schra was enlisted because of his expertise. He had knowledge of the field. He was willing to speak up. He also had knowledge on how to examine scientific images in academic papers to see if they actually were represented in a truthful way. He had that expertise because he had been making these scientific images himself for many years and had become familiar with the tools, the digital tools to examine the images. So Matthew Schra then was enlisted by the attorney representing these neuroscientists, who are, again, also short sellers in cassava sciences, to help them understand whether their fears and suspicions about the images in the papers that underlie some of the work into this drug the company was making were believable, were correct, were represented in an honest way. And so he was paid $18,000 by this attorney to contribute to what became a petition to the Federal Drug Administration. And this petition was asking them to pause the clinical trials and reevaluate the science behind simufilum. And Schra's contribution was to examine the images in the papers underlying the drug to understand their veracity. And what he found was that numerous images, dozens and dozens, appeared to have been doctored in various ways. And that's how his involvement started.
So let's move forward then and focus on how Schra moved from his initial investigation to eventually investigating, by a similar method, I assume, the images in that huge 2006 study that has informed so much of Alzheimer's research.
Yeah, so what Schra did is that he was continually trying to refine his ability and skill and understanding of how to evaluate these images associated with the cassava sciences work. And so in the process of educating himself, he went to a website called PubPeer, which is kind of a forum for people who have questions about the veracity of scientific studies and want to pose questions for other scientists to evaluate those studies. Often this involves scientific images. And so he went up on the website and he made a search for the word Alzheimer's, and up popped a few studies that caught his eye by this scientist from the University of Minnesota, Sylvain Lesny. And the comments on this PubPeer website indicated that some people had seen some of the Lesny studies and said, wait a minute, these images don't look quite right. They look like they may have anomalies that possibly could invalidate the findings of the studies themselves. And normally the way this works is that people don't say these were falsified or don't say that this is an example of scientific misconduct. They say, look, we have questions. Would the author be willing to provide more information, higher resolution images to examine, and explain what might have gone wrong here or why this is correct? And I might add that that's Schra's view too. He does not claim fraud. He says, look, these are red flags that need to be more fully investigated and examined in a more detailed way to determine what happened. So once he realized that there were some concerns about Lesny, he thought it would be important to look more fully into Lesny. So he did a search for all kinds of other Lesny papers and started to examine them in a methodical way. And what he found started to really concern him, because in paper after paper, image after image after image, going back 2 decades, he found papers that appeared to have suspect images that may have been manipulated, may have represented things that the experiment didn't actually support. One of the studies that he found was this seminal paper in Nature in 2006. And this was back in December of last year. So it was months after he had done his initial work on the cassava sciences issue. He found this set of suspect images in the Nature 2006 paper. And this, he realized, was potentially a big deal, because he knew that this was an influential, important study that had had a big impact on the Alzheimer's research field.
If you can briefly maybe explain, I know it's hard to do without visuals, but what he saw that was wrong with those photos.
In this field, in the basic research in examining these proteins that are blamed for the symptoms of Alzheimer's disease, there's a technique that's used by scientists called Western blots. And this is an imaging technique that separates proteins by their molecular weight. And so one of the reasons they're concerned about that is that the specific molecular weights of the different proteins could identify proteins that have a bigger or smaller effect in cognition or in the development of Alzheimer's disease. So, for example, star 56 is regarded as a high molecular weight protein. And so if you do a Western blot and it separates the proteins by size, you can see the presence or absence of star 56. You can see the relative amount of star 56 in the sample that you're testing. And the way it displays is it's sort of like usually in the shape of an oval, but a kind of you might call them blobs. They're called bands. What the Western blots do is they stack the proteins in a column by molecular weight. You see these stacked bands showing where the proteins are, when they occurred in the life cycle of, say, an animal, or what different kinds of people's brain samples they occur in. And this is critical to understanding whether an experimental technique is operating properly. It's critical to understanding what influence these proteins might have in understanding Alzheimer's disease. So what Schra did, and what many people have been able to do, is to look at these stacked bands in these Western blots and examine them in a variety of ways, including higher resolution, including using certain kinds of filters to change or increase the contrast so that features that aren't normally visible in a published image in a magazine become apparent. You can often see cut and paste marks in certain Western blots if they have been falsified. And these cut and paste marks may not appear in the published image, but when you look at a higher resolution version of it, or when you change the contrast, they become visible. Or you can find cloned bands. In other words, you can find places where apparently an experimenter may have copied a band and pasted it somewhere else in the image to support an experimental method. So again, Schra is not definitively saying this is what happened. He's not saying we know that fraud or misconduct occurred. He's saying, look, there's a lot of evidence that bands were copied, that they were moved around, that they were cut and pasted between images or within images, that other kinds of images, not just Western blots, but micrographic images, were altered or changed. And because of that, because of this image after image after image, paper after paper after paper, including the very important paper in Nature in 2006, he had to conclude that there was a serious problem here in an area of research that had been quite influential and that had steered a lot of thinking in the field. So he knew that he had to create a much stronger, deeper, more broad look at that work and build a dossier that could be used by investigators to examine it more fully.
So where does that investigation stand now? What did it find out?
Schra created a dossier on the Lesney work, which includes a number of papers that he did jointly with Karen Ashe, also with other investigators. And Ashe did this dossier, and he found probably around 70 plus images that appeared to be suspect, indicting essentially the entire body of work. Now, what he did with his investigation is, first, he gave it to the National Institutes of Health that supported this work. In other words, that's the obligation of a whistleblower, to give it to the funding agency so that they can do their own deeper look at it. Second, he provided the results of his investigation to numerous journals that published the articles, including Nature, to ask them to do their own due diligence to perhaps retract the paper or to issue expressions of concern associated with the paper and tell readers that they were examining it more fully. So he took those two important steps. What he also did is he shared his work with me. And the reason he did that is that the investigation wheels turn very slowly when you talk about federal agencies or universities or journals. It can take many months, sometimes even years, for anything to occur after the complaint is made. Meanwhile, the scientific thinking in the field may have still been influenced by work that will later prove to be falsified in various ways. And what I found that every single person that I showed these to, from these two categories of experts, they all agreed that his findings were strong, they were well validated, they didn't agree on every image. Not everyone agreed that every image he flagged was improper or potentially doctored, but they said that the body of work, his dossier as a whole, was deeply concerning, and that it was so well constructed as to be convincing to them.
I've waited to ask you this, but what does Lesney say about this? Surely these concerns have been raised to him. He's had an opportunity to respond.
He's had many opportunities to respond. Lesney would not speak to me. He declined. He actually never responded to my interview requests, nor did he respond to my request that he answer questions that I sent to him via email. Similarly, Karen Ashe declined my interview request. She did communicate with me briefly in email, and her comments are in my article, although she does not answer any of my questions. I should say that when I went to Lesney and Ashe, I was very, very careful to ensure that they knew exactly what I was working on, that they knew exactly what my questions would be, so that there were no surprises. They understood the gravity of the concerns, the extent of the concerns, and the way at which it could threaten one of the most important papers that either of them had ever been involved in. So there were no surprises there, but at the same time, they haven't said anything. Now, since the stories appeared, and there's been considerable public interest and media interest in it, Lesney has gone to ground. He has not said a word to anyone that I'm aware of, and his university is investigating his work and the work he did with Karen Ashe.
What has this done to the world of Alzheimer's research in general, and what happens next?
The world of Alzheimer's research has been in a bit of a frenzy associated with the concerns raised in my article. There's enormous debate in the field. Some news reports have described this as invalidating the entire amyloid hypothesis. I think this is a real overstatement. There's an enormous amount of excellent research that's gone on. I think what it does mean is that the world of Alzheimer's disease is being forced to take a look into the mirror and ask themselves, what must we do to examine the scientific record and understand the ramifications of the potential steering of the field by a body of research that has been shown to be possibly the result of misconduct. And so the debate is serious. Many people are saying, look, we don't want to overstate the importance and significance of this. There's many other studies that have been shown to be very fruitful. I think that that's a cogent and important way of looking at it. At the same time, I think people that discount this as somehow unimportant might be operating in a self-serving way because they're trying to protect the validity of their research, their future grants, and the credibility of a field that has long since begun to question their own assumptions about amyloids and now has a much bigger reason to do so.
Charles, thank you so much for your work on this and for sharing it with us.
Thank you. Thank you for having me.
Charles Piller, investigative journalist for Science Magazine. That was The Big Story. For more, you head to thebigstorypodcast.ca. You can scroll back as far as you like. Actually, I think you can only listen to our past 300 episodes on there. We're working to get all 1,000 plus of them stuck on that website so you can listen to our horrible first episodes that I'm still embarrassed by. In the meantime, you can talk to us on Twitter at TheBigStoryFPN, and you can email us, hello@thebigstorypodcast.ca. You can also leave us a voicemail at 416-935-5935, but you know what's even better than a voicemail? Some real reviews on Apple Podcasts or any other podcast platform that lets you tell us what you think for the whole world to see. I don't even care if they're bad reviews. We just got a 5-star review, and I will take those 5 stars that absolutely ripped us to shreds. Now, say what you want, I'm still walking away with those 5 stars. Thanks for listening. I'm Jordan Heath Rawlings. We'll talk tomorrow.